Okay, so sorry about that.
No problem.
It says host disabled participant screen sharing.
I did just have to make you a co-host again. So, okay, you should be good to go now.
Okay, thank you. Okay, so my talk is about using Shiny to avoid boring tasks at work. So for some background, in the summer of 2020, when we were all social isolating in the pandemic lockdown, I interned at the Brookings Institution, which is a think tank that does policy research. It's my first time doing mostly like qualitative research, so I wasn't totally sure what to expect, but I was basically helping scholars in the China Center prepare for panel discussions and writing research papers. So some of the common asks I would get were questions like, can you tell me or give me a list of what Chinese officials have said about the relationship between China and the EU in the past year? Or like what statements have Chinese officials made about the trade war? Because that was a big concern at the time. And so what this basically meant is that every day I would go to a website, which was usually the Ministry of Foreign Affairs. I would go to a link and I would click on it. And then I would skim the page and try and find the desired information. So maybe like information about the EU, if that's what the scholar was interested in. And then I would do this for several hours every day while in lockdown. And it made me really, really sad. And so because I had done data science work in the past, I thought it would be really great if I could just search a database. So since there was nothing else really going on because we we're all social isolating, I decided to do that. So I started with scraping the data from the pages that I often had to visit. So I used this Python package called Scrapy to scrape the data. So some of you might be thinking like, why would I use Python, especially at an Our Ladies talk? So I thought that it had a couple advantages over some R tools. So because I was scraping data from Chinese websites, there are a lot of different character encodings and not always like very standard ones like UTF-8. There's like a weird one called GBK that I found R often had trouble decoding properly. But the Scrapy package in Python handled it a little bit better in an automated way. The framework for Scrapy is pretty easy to set up. You just like type some Python code and it'll set up your directory for you. And it also makes it easy to adjust parameters for scraping. So websites will have a file called robots.txt, which will tell bots or robots how to politely interact with the page. So that's like an easy setting for Scrapy where you can just say obey robots.text equals true. You can also manage how many concurrent requests you're sending to the website. So how many times you're hitting the web page at the same time. You can do auto throttling. So if the web page is like, you're hitting me with too many requests, Scrapy will automatically slow down. And it also has really good tools for logging. So you can check your progress and any bugs really easily. And it runs super fast. So I was able to scrape like the entire website in maybe 10 minutes. And I had nothing better to do. So I thought it'd be great to learn some new skills and tools. And then after collecting the data, I cleaned the text. So I collected both English and Chinese data. So for the English data, I used this function called unnest_tokens from the tidytext package. And what that does is it basically took my data where each row was the response to a press question. And it made it a very long table where each row is a token. So this is taken from the tidytext vignette, but you can see how it maintains the structure where you know that Sense and Sensibility is like one line of text. So that's how I tokenized my English data. And then for the Chinese data, because tidytext doesn't work well with languages other than English, I had to like write my own custom code for it. So I used this package called Jbar, which is good for tokenizing Chinese text. And I had to write this like code to loop through each response to the question, tokenize the text and split it out, and then name the list, make it a data frame, unnest the data frame, and clean up the column names. But in tidy text, this is just one function. So that's the advantages of using the tidy text package, and I highly recommend. And then I made a Shiny app. So I put all my filters on the top of the page, so I could filter to like a specific date range, because I was often asked to look for statements within a particular period of time. And I made my searchable database on the bottom with links to the sources if I need to double check things. And I also made a fun word cloud because I had nothing better to do. So for people who are interested in making word clouds with non-English text, I found that the word cloud 2 package was a lot better than just the word cloud package due to encoding issues. And then I hosted it on shinyapps.io for free and shared the link with my manager. He thought it was very cool, and I got to spend less time clicking through pages all day. So it was like much happier, and went for long walks instead. And that is my talk. Thank you for listening. And there's links to my GitHub repo and Shiny App here.
Great. Thank you so much, Claire. That was great. So next, I'm going to invite Crystal to speak, and she's going to be presenting a comparison of packages to generate codebooks in R.
All right, that was super cool, Clara, by the way. All right, let's see. All good?
Yep.
Okay. So yeah, I'm going to be talking about a comparison of packages to generate codebooks in R, and I'm Crystal Lewis. So whether you're in academia or industry, it's common, obviously, to share data with collaborators, and it's important that along with your data, you share some form of documentation, right, that allows your collaborators to use and understand your data. One type of documentation is a codebook. So this is often used for survey instruments. It describes the contents, the structure, and the layout of a data file. And it enables the user to quickly ascertain some of the details about a data set without ever even actually opening a file. So I started searching for R packages that produce codebooks, so I didn't have to make these by hand. I initially found and reviewed about 10 different packages, and I narrowed this presentation down to 4 based on 3 criteria. So the first criteria was that I wanted the package to be compatible with the class Haven labels data. I work with a lot of academics who use SPSS and Stata, and so it's important to me that the package integrates well with data that has embedded metadata like variable and value labels. I also wanted the codebook to be human readable, so I wanted it to print out to like a text or a Word or PDF document. And then I wanted it to produce this variable level information. So these are 15 summary statistics that I think are important for getting a holistic picture of what's going on in your data. Before we review the packages, I wanted to introduce some example data that I used to test out the codebook packages. These are just made up responses to a few survey items that I found online about pet ownership and attachment, and I just kind of thought they were fun questions to work with. But we have 3 questions about pet ownership, as you can see here, and they all have a response range option from almost never to almost always, and then they have this user-defined missing value of -99. So we can see here that our data has this embedded metadata. So our 3 main survey items are all class Haven labeled, and you can see the actual question wording is embedded as variable labels, and the response options are embedded as value labels. And then we have these user-defined missing values of -99. And so this is the kind of data I wanted to work with. So this table here gives you a quick overview of what statistics can be exported by each package. But we are going to go through each package one by one now. But you can review some samples of the code and output from each of these packages in my GitHub repo, which I linked in the footer of these slides. So the first package I reviewed was this codebook R package. It has one function that allows you to create a codebook, and that function is codebook. The codebook function creates an R.docx object using the flex table and the officer packages under the hood, which you can then print to a Word document using the print function. Like I said, it prints to a Word document, which makes it really easy to manipulate after you export in case there's like additional pieces of information you want to add. It works really well with Haven label data, and it recognized all of my embedded metadata. And there are also options to add variable attributes such as labels if your data doesn't already come in with that metadata added. or you can add additional metadata like variable skip patterns if you wanted to. And then it provided all the summary statistics I was looking for, which was great. And it also has arguments to add project level metadata like title, author, project description, that kind of stuff, if you wanted to add that to your codebook as well. The second package I reviewed was the codebook package. It has this function new codebook RMD, which creates a pre-populated RMD file for you to work in. It's that image over here to the right. That's what the RMD file looks like. And then within that RMD file, there are a few different functions you can use to build your codebook. But ultimately, the codebook function is the one that creates your codebook. And then you can render that file to get your full codebook. This prints to HTML, Word, PDF, and other formats, which is pretty cool. It works fairly well with Haven label data. The only thing I struggled with is getting the function to recognize some of that user-defined missing values, but otherwise it worked really well. There are options to add variable attributes, again, to your data if it doesn't already come in with that metadata added. It provided most of the summary statistics I was looking for. It was just missing a few. And this package does, however, provide some additional statistics that may be beneficial to some people, like scale reliability estimates, like Omega. The third package I reviewed was NNIST, if that's how you say it. In this package, the codebook function creates a codebook object, which you can then write out to a text file. I really like the simplicity of this package. It prints a very simple but clear text file. It works really well with Haven labeled data, and it recognized all of my embedded metadata again. And again, there are options to add variable attributes if your data does not come in with that metadata added. It provided almost all the summary statistics I was looking for. It was just missing a few. And it also provides some additional statistics if you want them, like skewness and kurtosis of variables. And then the last package is the SJPlot package. The viewDF function creates our codebook, and then there are several arguments that you can use in this function, but I included the ones that got me closest to the statistics that I was looking for here. This function only prints to an HTML file, which might be really good for some purposes and less great for others. It does work really well with Haven labeled again. It recognized all of my embedded metadata. It includes almost all the summary statistics I was looking for. It was missing a few again. And then there are several argument options, like I said, that you can include to control the level of detail you want to show in your codebook, which is really nice. So like I mentioned, I initially reviewed 10 packages, but narrowed down to 4 today because they either didn't work well with Haven labeled data or they didn't meet enough of the criteria I was looking for. But if you're interested, you can review a table of all the packages I tried out in my GitHub repo here. And that's it. Thanks for listening.
Thank you. I did so much work with code books at my last job, and I wish I had known about these packages.
Yeah, it's been really fun getting to dig into all of them and see what works best for our purposes. So.
Yeah, I had no idea there are so many. So, yeah, so thank you so much. That was great. So next I'd love to introduce Blair, who's going to be speaking about map making data stories.
All right. Hi, everybody. Let's see if I can figure out screen sharing. There. You can see what I'm doing here? Great.
Yeah, looks good.
All right. So map making data stories. Essentially, I want to do a really high level overview of opportunities for map making that could apply to your work that you might not be thinking of. And then specifically high level glimpse into Leaflet and Tiny Geocoder, which are the packages that I use for it. I saw on your website that you have a speaker tomorrow doing map making using totally different packages. So there are a lot of ways to do this. This happens to be the way that I have done it myself. So as data people, we are accustomed to spreadsheets. A spreadsheet can be a beautiful thing, but if you want to tell a compelling narrative or discover one, is this really the most interesting thing to look at? No, of course not. Spreadsheets are incredibly dull. So how can we make this feel a little bit more dynamic and engaging and an opportunity for discovery? Maps. So also, actually, are you, oh, you can probably see me seeing myself, don't you? Is that better? Anyway, no, okay.
We can't see it, it's just your slides.
Oh, great, okay, because I see all of you guys. So when might you use a map? So there are many opportunities, 2 that come to mind. are spaces where your audience may connect more easily with the visual rather than written or numerical information. So specifically, I can tell a story in service delivery. I used to work with the Colorado Department of Human Services, and we administer the TANF welfare program. Part of that program involves supplementing childcare funding for families that need daycare so they can go be employed. However, I can pull a spreadsheet like the one I showed before and show how far every family in the program is from the nearest childcare agency. That is not a compelling story. What is a compelling story to people that need to make policy change is a map where you can see, wow, there's a childcare desert here. We may offer funding, but families in this region are not going to be able to seek employment. Also, to explore your data more deeply. So we also had a circumstance where we had a dramatic decrease in applications in a region, and my coworker could not figure out why, threw it on a map, and I knew that area very specifically and was able to identify the problem as being related to geography. So maps are a really great way to communicate with non-data people, but also with other data people who may have a different degree of familiarity. As I mentioned, the packages I tend to use are Leaflet. It's a package you can use to make interactive maps, and you can also embed it on a website if you want to share it, or you can just play with it yourself if you want to do some data discovery. And Tidy Geocoder as a resource to take addresses and turn them to longitude and latitude, or vice versa as you need. So I did not realize I was going to be opportunity to screen share, so I'll actually give you a very brief glimpse into what this map looks like, except I cannot seem to, there we go. Okay, so with Tidy Geocoder, here's an example of a map that I made of Colorado breweries and bike trailheads. You can see little martini glasses, you can see beer glasses, radiuses for approximate distance from bike trailheads versus walking distance trailheads. And so by engaging with this, you can really kind of get a sense of, if I want to have a beer and ride a bike, where do I need to go and what parts of the state am I going to hit some limitations in? I'm asking the important questions here is what I'm trying to say. So at a very high level, how did I make this map? So what I did is I prepped the data initially by setting up my geocodes. And I should mention that geocoding addresses can take a really long time, like up to 1 second per address. So I strongly encourage exporting to a CSV once you do all of your work, because I hate having to run that code more than once ever. We also can pull out different subgroups for comparison on our map. So in this case, I got sales rooms and bike stations. And I apologize, it's so fast, but 5 minutes. And then I can also create different icons using Awesome Markers package. In here, I can actually create my legend for my map. So it's clickable, as I said, and interactive. Some tiny brief considerations are that Tidy Geocoder is not HIPAA compliant, but you can control users' ability to zoom in and out on your map itself. And there are a bunch of other cool and awesome features that you can put into your map. But at a very basic level, if you just want to understand how geography impacts your work, this could be kind of a resource to consider as you do. And I know I'm slightly over, but I'm just going to very briefly show that you can layer things like an income map on top of your map. You can also, if it'll actually load, here, income, so you can see how poverty interacts with your map and regions. Then you can do some aesthetic features as well, weather, whatever it is that you want. So I will leave it at that. Thanks, guys.
Thank you so much. Yeah, I only really knew about leaflets. That was very interesting. Okay,
So easy to use.
Oops, yeah. So next up, I would love to introduce Susmita on behalf of Northwell Health, who will be speaking about logistic regression in the Tidyverse.
Hi, everyone. Thank you. Can you hear me okay?
Yep. Yeah.
Okay, great. Thanks. Hi, everyone. This is Mina. I'm a senior data analyst at Northwell Health on the digital patient experience team. I'll hand the microphone to my colleague, Joritza. She'll be also presenting with me, and I'll let her introduce herself briefly.
Hey, guys. My name is Joritza. I am also my title is Senior Digital Research and Analytics Analyst at Northwell Health under the Digital Patient Experience team.
Great. Thank you. So here we'd like to talk to you all about a regression analysis we had done in R. A regression, as a brief refresher on regressions, they fall into a category of a supervised machine learning algorithm, which is a predictive model based on both input and output data. In this particular analysis, we ran a logistic regression model to predict a binary outcome based on historical data. To give an example of the type of question we can answer, how do temperature, humidity, and wind impact the odds of seeing sun versus rain? And in this particular project, we use odds ratios to understand the likelihood of a particular event given a particular exposure. To give some context, at Northwell Health, Joyce and I do work on the digital patient experience team, and one of the aspects of our product involves sending communications in the form of email and SMS confirmations and reminders after patients have scheduled their appointment. And for this analysis, our primary research question asked, how likely are patients to attend their appointments if they received communications beforehand? Here's a quick snapshot of the code that we wrote. The primary packages we used were dplyr, tidyr, Broom, and GT Summary. dplyr is excellent for data manipulation challenges, and great to have since it's so efficient. We were able to spend less time waiting for a chunk of code to run. tidyr, which is excellent for changing the shape or hierarchy, whether by pivoting or nesting on nesting data sets. A huge amount of gratitude to the Broom package, which takes the messy outputs of built-in functions in R and turns them into tidy tables. And last but not least, GT Summary, which is a great way to create analytics and summary tables that can be publication and presentation ready. It's excellent for summarizing regression models particularly. On the right is just a code snippet of all the functions we used from these packages. Now I'll hand it to Dritsa for the final slide.
Hey guys, okay. So we grouped a few times to be able to discuss other factors that we thought would be interesting to include, whether they had an influence or not on this question. And so we decided to take a look at the following factors for this analysis, which was patient age, patient gender, is the patient an app user, how far in advance was the appointment booked, was the appointment online bookable, and did the patient receive any email or text appointment confirmation and reminders. During the engineering process, our priority was to make sure that we were pulling these variables from the right places in the right way and making sure that the data is as clean as it can be. After importing the final data set in R, the table on the right would usually show us the end result. We did exclude the results since we are still in the process of examining the results and extending them across our organization. But this is basically what our end result would look like, and we're hoping and we're excited to see like what the results are. And that's pretty much it for us.
Thank you all.
Thank you.
Thank you so much. That was great. So our next speaker is Natalia, who will be speaking about creating an R Center for Excellence in a large pharma company.
Hi guys, thank you. Thank you so much. I hope you can all see my screen. So my name is Natalia. I'm a data scientist at Pfizer, and I'm very grateful for joining this Our Ladies New York session because I'm located in North Carolina. So thank you so much for having me today. So in this lightning talk, I would like to tell you about Pfizer R Center of Excellence and the value it brings to our company. And hopefully it will inspire some of you to build the R community within your organization if you're thinking about starting this journey or you don't have one already. So Pfizer is a big organization with thousands of people worldwide. How many of these people actually use R? Well, based on our installations through the official software deployment process, around 1,500. And this is a lot of users. And who is out there at Pfizer using R, and what are they actually using it for? There are some colleagues who engage within R at Pfizer Microsoft Teams channel, and we have a reasonable clue of what they're actually doing since they ask and answer questions and participate in conversations. But the Teams channel only reaches 600 people, and that's not even half. So on top of that, 1,500 number doesn't count folks who go directly on CRAN and download R. With this number of users, we can safely assume that there are different levels of competency in R within our company. So some R concepts that are struggle for a beginner can be explained by a seasoned programmer fairly quickly, and this interaction between beginners and experts will benefit both. And how do we connect beginners and experts, especially for parts of the organization that don't have an expert on hand? And also, how do we avoid solving problems more than once in different parts of the organization? That's quite a challenging task. So in order to answer these questions and avoid silent groups working in isolation, we solved this problem and we created the R Center of Excellence, which consists of two main groups. One is our core team and another one is our SWAT team. The two groups work together to accomplish the following goals. They define and document the processes around use of R at Pfizer, work with IT to maintain the extent of our infrastructure, help business lines develop and deliver training, build our user community, and increase external outreach. The core team leads the way on the initiatives you see on the slide. So it builds an internal R community and communication channels. The team collates, curates, identifies opportunities for new training material, distributes information about advances in R through newsletter to keep community updated on cutting edge technologies and new R packages, adapts new processes, ways of working, automation, and influences external environment through cross-pharma initiatives that we have going on in pharma, like R Consortium, R in Pharma, and so on and so forth. And the core team also helps the SWAT team to prioritize and identify opportunities for consultancy. And all these pieces together build the culture and strategy around R within the organization. The R SWAT team also has its own objectives. It provides technical input to experts and training and help for beginners. It helps developers to go from code that works to code that is sustainable for the long term, avoiding and reducing technical debt. And it also connects colleagues who are looking for a solution to a particular problem with the ones who already solved this problem. And it also provides strategic solution to various problems across the organization that can or should be solved with R. If this talk resonates with you and you would like to build a similar team within your organization, there are three main elements that will be beneficial to have if you're starting this journey. So first, start building an internal community, interactions and sharing best practices like we're doing right now, very important, and create a welcoming environment for asking questions and also answering questions. Find mentors who had experience building similar communities or teams in the past and involve them in the process. Or if you're familiar with your organization's needs and processes, become a mentor yourself. And finally, have a clear vision. Define your goal, know what you're trying to achieve and how to get there, and then communicate it to stakeholders. Tell them how building our community is going to benefit them. It is very important to get leadership support, otherwise it might be an uphill struggle. And with that, I would like to conclude my presentation and give thanks to my colleagues and special shout out to Mike, who presented about our Center of Excellence in London earlier this year and inspired this talk. Thank you so much, everyone.
Thank you. Yeah, as someone at a very rapidly growing healthcare organization, that's very relevant and interesting. So thank you.
Oh, I'm glad. Thank you.
Okay, so our next speaker is going to be Daniela, and the title of her talk is Air Analytics.
Hi, everyone. I'm just going to pull up my slides. So for a little bit of background, I have a policy background, but right now I'm getting my MPH in environmental health. And this was like a summer job that I did with a nonprofit. And they're focused on air quality monitoring. So if you aren't in like the climate space, air pollution is a really huge issue. It's the fourth, in 2019, it was the fourth leading risk factor for mortality globally. In California in particular, where the nonprofit that I was working at was based, is one of the largest non-attainment areas in the US, just meaning that they basically don't meet the federal standards for air pollution. And a lot of that is agricultural activity. And obviously California is a really big state, but even in Northern California, they're dealing with a variety of pollution issues, especially like wildfire smoke related. if you're not from California, I feel like this picture became really popular in 2020. And it was actually in September as well. So yeah, I mean, there's just a lot of smoke, ongoing wildfires and droughts. So this project was based in San Francisco. And San Francisco is a really small city, but this map is just to show you like the distribution of the highways and the neighborhoods, if you can see my cursor, where they're concentrated. And then another map highlighting green spaces in the city, which kind of mitigate pollution exposure. So you can see that the green spaces are basically all the way to the west side of the city, and highways are concentrated in the east. So that creates a huge environmental justice issue, basically. So that little star is where the nonprofit is headquartered. And then this red box is the area of the city that they set up air quality sensors. So these are the air quality sensors that we used, and we set them up on smoke days and good days, basically any type of weather. And there's like 19 of them now. So you can see like each dot is a sensor. So the distribution is pretty much almost the whole city. And what I was trying to do is basically take all of this data and analyze it through the lens of a layperson, because a lot of the audience for this data or public facing material that we create are non-technical. They're like low income, like not policy related people. So we were trying to make it as digestible and as like sticky for them to remember and just raise awareness on the air that they're breathing, because they do have the highest exposure to it, but obviously like not that many tools to do much about it. So these were kind of like the main buckets that I was looking at, and I wasn't pulling that much public data. A lot of it was just cleaning up and then analyzing the sensor network data. So it was all like in-house, but I was just trying to find patterns that might be of interest to these residents. So this was like average PM 2.5 by weekday. And for some reason, like Tuesday just happened to be the lowest day of the week across these 2 years. And obviously with the pandemic, like traffic congestion and traffic patterns changed a lot. So that was interesting to look at. I also made some time series for them just so that they could see like the different peaks and non-peaks of the year and how that lined up with temperature, season, all of that. And these were all like very basic R graphs, I would say. Like it was ggplot and a little bit of time series, but like I would still consider myself like an R novice. So I'm still learning how to make them a bit more, I don't know, advanced, but I think they got the message across that I was trying to get across. So this is just, for example, like an inverse relation of temperature. So higher PM 2.5 in the winter and lower PM 2.5 in the summer, which I think a lot of people would assume otherwise. But yeah, so I think I was just trying to show them what's happening around them, what's happening in their neighborhood. And a lot of this is like an introduction for myself of how to translate climate science into action, because obviously we're raising awareness on the community level, but we're also showing this to government agencies, urban planning offices, a lot of different audiences. So just trying to make it all accessible and digestible. And yeah, I thought it was really interesting. I mean, air is a really huge and complicated issue. And this is just one very local project in San Francisco. But I thought it was a really good introduction of applying like these R skills that I had learned in the classroom in my MPH and finding different ways to present it. So yeah, that's my contact. And that's basically it.
Thank you so much. And yeah, it's such an important project. Okay, so our last speaker for tonight is Dorota, who will be presenting Base R versus Tidyverse Regular Expression Edition.
Thank you, Emily. Hi, everybody. My name is Dorota. and I'm actually a member of the New York City chapter board. So thank you all for coming today. So today I'm going to be giving a very quick overview of regular expression and sort of comparing the functions that are available in base R versus the Stringer package in tidyverse. And I'm doing this as a follow-up to a previous presentation that I gave where I just compared in general the syntax of base R versus tidyverse functions that are commonly used. And so I'm doing this sort of R wars theme in my presentations. So what are regular expressions? So regular expressions are a concise and flexible tool for describing patterns in strings. So here's a basic example, right? You have the pattern stat, which will match the exact occurrence of the letters STAT in that specific order, regardless of where they occur in your string. So here's a sentence. I restated my preference for statistics, staplers, and my thermostat. I don't know what this sentence means. I just wanted stat to show up a lot. But basically, if we do a regular expression search for stat, the pattern stat, it'll show up 3 times in this one sentence, regardless if it's in the middle of the word, at the start of a word, or at the end of a word. So regular expressions can be very useful if you need to match a full pattern or a partial pattern. If you need to identify like a phone number or a zip code or an address, something like that. You can search for numbers, you can search for letters. It's extremely, extremely useful. You can search for substrings. You can extract parts of your string. You can search and then replace strings. And you can also split your strings into tokens. So the other flip side of that is that regular expressions can get very complicated. The syntax, especially to me, is pretty complicated. So regular expressions contain characters, also known as literals. So like, A, B, C, D letters, right? But they can also contain special characters, which can have multiple meanings and therefore need to be escaped if you don't want your code to interpret those special characters literally, if you want to use the other meaning of that special character. So on the right here, you have a little table of a few special characters and what they mean, and then how you would escape them with the backslash. Give me 1 second. Sorry about that, just had to close my door. So now on to the comparison of base R versus tidyverse, right? So in my research, I really only found a handful of functions that are available in base R that are pretty commonly used. So that's grep, grepl, sub, gsub, string split, and then there's a few others that I actually haven't really used that much, and they kind of were similar enough to these other use cases that I didn't bother really going into them. But essentially all of these functions, search a pattern and then return either like the location of that match, or, in the case of grepl, it's a logic value, true or false, whether there's a match. Sub and gsub will replace that pattern that you're looking for. And so on and so forth. Whereas on the right here, I listed a few of the Stringer functions that I commonly use. And there's a ton more that I didn't list here, but these are sort of the ones I go to most often. And really, they are pretty analogous. Like string detect will find your pattern and return a true or false if it found it. String replace and other variations of that, like string replace all, will do the same thing as sub and gsub. And then there's string split, which has the same name just with an underscore. So I did find these functions to be pretty analogous. The advantage though, while base R functions do work and are very solid, they were developed over time, kind of organically as these needs came up. So they can be a little inconsistent and potentially hard to learn. Whereas on the other hand, I find the Stringer functions to be more consistent in terms of the function names and the argument names, and as well as the output that they produce. So, personally, I lean towards Stringer a little bit. It's just seems cleaner and a little more readable, which I always prefer in my code. That said, though, use what works for you. And that's it. Thank you.
Thank you so much. So that was our last talk. So thank you so much to all of our presenters. We had some really great talks. I saw a lot of the conversations continuing in the chat. So thank you for your willingness to answer questions there as well, and for all the great questions that came through as well. And yeah, thank you everyone who attended for giving us your time. Yeah, unless you have anything else, Anthony, I think this wraps us up.
Yeah, I just wanted to say to echo your sentiment. Thank you, everyone. Those talks were all awesome. And assuming we have permission from the presenters, we are happy to share GitHub links to everyone who RSVP'd. So yeah, look out for that. And thank you all for coming.
Yeah. Thank you. Have a great night, everybody.
Thank you. Bye-bye.